Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next problem in the list is not actually here, but it's a problem which definitely requires binary search approach, but it's not in my list. But I'm gonna just really quickly solve it and just move on with the medium level problem. So this is easy problem on LeetCode. It's called a square root of x. So basically, given a non-negative integer x, return the square root of x rounded down to nearest integer. So what does that mean? Actually, the number 16's square root is 4, but what about 15? That is not 4. It's going to be less than 4, but it's more than 3 because 3's square is 9. So it's something between 3 and 4, which will be 3 point something something. But what we're going to return is 3. That's what the definition says. So let's go implement it. So how are we going to do it? And let's read these two as well. So you must not use any inbuilt exponent function, which is basically Sqrt, and you put the number in. It should provide you the square root of that number whatsoever. So what is square root of 4? That is 2. Square root of 8 is 2 root 2. So we're going to return 2 because root 2 is like 1 point something something something. We don't want that, so we just returned 2. All right, so there are two ways of finding the square root of x. For example, we can take anything, like let's take for example, let's take 17. What is square root of 17? That is 4 point something. That's what I'm like, 4 point something. So we return 4. So there are two ways of solving this. First way is, how about we start a loop at 1 and then go up to basically 17, and I is basically moving forward from 1 to 17, and we come across a number k, and we check if k square is equals to 17. If it is, then you return k. Otherwise, you check basically the last number, which was, you stop at a point where k square is basically greater than, by the way, if it becomes greater than 17, that means we have a variable called result, and then you just store it, and whenever this becomes, you break and return basically a number, either k minus 1 or like just result. Have like third variable that just stores like whatever numbers is the largest number where that result square is still less than or equal to 17. So but this thing will take the time complexity of under root of n, where n is this number, the square root that we're trying to find out. But can we do better? This we have done this kind of problem previously, so this is easy to do for you guys, I'm sure. But can we do better? Yes, we can. We're going to use binary search. How do we do it? Oh, by the way, like I know I'm like rushing through, but honestly my objective here is to understand these problems and get through like as quickly as we can, because these are easy problems. We really want to just get around with these easy problems and get to the medium level problems, because that's where the actual intuition happens, and that's where the real questions are asked, by the way, in most of the coding interviews. So if my number is basically given to me as 17, then basically I'm trying to find that k where k square is less than or equal to 17, and k must be basically, I could choose 1 or 2, but like I'm trying to actually get as close as to 17's under root, by the way. So how about instead of just using a for loop and finding that I or k where k square is equal to 17 or less than or equal to 17, I want to do is have 2 pointers, left and right, and use binary search, find that mid So 17 and 1, which basically be 17 plus 1 is 18's half is 9. So let's say 9 is located here. Is 9 square less than equal to 17, or 9 square is greater than equal to 17, or 9 square is equal to 17. So this is not true, this is not true, this is true. So what we're gonna do, what we will do is we will bring our right pointer from 17 to basically mid minus 1, which is 9 minus 1 is 8. 8 would be over here, and then we again try to find, and at the end we will reach at a point where our result or r pointer will be basically pointing to something like, left will become greater than r, that's where our while loop ends, and right will be pointing to, I think in this scenario it will be pointing to something like 4, and that's what we return. And I think whatever I said, if you're smart enough, it has gone into your brain. If you're a math student, if you're not, then I'm a bad teacher. There's no bad student, only bad teachers. But my point honestly is just to inspire rather than teach. Okay. I don't know what I'm saying. Well, anyway, like this is an easy problem, and I'm sure this was not even in my AlgoYogi list, but I'm just gonna write the solution also really quick. Okay, so what we do is we have a left pointer, we have a right pointer pointing to basically 1, and num is x. Okay, so while left is less than or equal to r, less than or equal to r, then what we do is find the mid. Mid is basically left plus r minus left divided by 2. All right, and I'm gonna just wrap this also up. Then what I want to do is, if this mid into mid is greater than basically x, I want to bring down my right to mid minus 1, and if mid into mid is basically smaller than x, that means I want to bring my left pointer to basically mid plus 1, and this is where, let me have this result variable. Initially I'm just calling it 0, and I'll just update it over here. So res equals to left, and else case would be where it just actually became equal, so we just return mid, otherwise you just return x. Okay, let's zoom out. I'm not gonna spend like too much time on it, I'm just gonna simply run it, and voila, just a little bit of some mistake. Output is 8. 8 should not be the output because I was supposed to return res, not x. What happened? Okay, so if mid was greater, that means I was supposed to bring my okay, sorry, not this. It should be actually mid, because what I did is like I incremented like I basically chose the upper limit. That's not what I'm gonna do. I want to still keep, if I found, let's say I was trying for something like 17 and then found like some 5 number or like 4, later I'm incrementing it, then I still want to keep my result as the mid 4, not like 5, what this must have done. So I think I'm gonna submit it now, please. Yeah, okay, zoomed out. So let's write the time complexity. Binary search approach is gonna be big of log n, and space complexity is going to be since we're not using anything, it's going to be constant. Let's go to AlgoYogi. We do not have the problem in the list, but still, let's mark it done, and see you guys later in the next problem, which will be like, we'll be starting the medium series now, like, you know, not the series, like the medium set of the problems, which are the real problems in my opinion. Until then, bye bye.